Alright, so in order to fully understand this theory and how everything's working together, we have to understand first relativity. Alright? Relativity states that if you're in zero gravity and you're in a box, everything's floating around you. Now, if you're in the same box and everything's falling in a free fall and you're in there looking, is there enough for you to tell? The answer is no. But what's weird is that light, if you were to shoot a beam of light from this side to that side, it'd be a straight line. But if you shoot a line from that side to that side, it actually ends up curving the line. Oh, there we are, down at the bottom. It ends up curving it so it reaches that point at the end. Now that's relativity in a nutshell. And there's really no way to tell. But I say that there actually is a way to tell. And it's a nice little workaround. But you first have to realize that 1 plus -1, when you're dealing with vector fields, does not equal 0. For example, if you have a force going this way and another force going that way, the net force in the middle is 0. But you could say that space has a density. You say density is the energy per area. Well, that energy per area would be measured in net. Right, so the density is net. Okay. Whereas saturation is gross. The gross amount of energy at that point. Okay? So, if we say that the saturation of space occurs with vector field information, okay, gravity, magnetism, and charge. The reason why I break charge and magnetism apart is because of the neutron not having any charge but yet still producing magnetic fields. So they are related when they move past each other and through each other, but they're not quite the same. Anyway, since we know that a more massive body has more saturation of space, we can then calculate the refraction, okay, using the density concept, but we're going to deal with saturation for the gross. So we have the angle of the vector, and then that changes over this plane, which is the change in saturation, and that gives us another angle. So we're able to use a constant. K equals tan theta angle over tan theta angle prime. Now let's keep going. We need to figure out the maximum saturation of space, which we know is 100%. But a nice thing nature does is it gives us a red flag of, this is the saturation of space, and that's black holes, okay? Because the saturation of space for a black hole has to be 100%. Has to be. Light can't exist there. Neither can magnetism. Only gravity exists, because gravity is blocking out everything else. So it basically makes it refract so bad that it spins in a little circle. Not that space-time is warped or anything like that, it's just a density issue. And because it's a r, since it decays at 1 over r squared, then there's a constant change in saturation, and that constant change in saturation causes constant refraction.